Welcome to the second of our Lunch and Learn webinars. Today, we're going to be continuing from the previous webinar where we talked about our TA modulator in some depth and also our TA slider. We really only touched upon the actual range itself and what's available within the range. Today, what I want to talk about is how we can actually digitally configure those actuators on site, how we can better utilize them and make our lives a hell of a lot easier. We're going to do something slightly different today. So rather than just sit here and talk to you and list a load of features that we can do with the actuator itself, we're going to actually go through some scenarios with the app and how we would control the actuator and how we would configure it, so we can actually physically see what you can do and what you can get out of the actuator as well. Oh, just a brief agenda. The topics we're going to sit on today are firstly connecting to the TA slider itself. We're going to cover configurations and folders. We're going to create a standard slider 160 configuration. We're going to upload that configuration and show you how the upload process works. And we're also going to do a quick remote control view. So this will allow us to see the actuator in operation. And if we've got enough time, we will try and cover some of the other settings and more, just to see what settings we can set within the app itself so we can make it work for us a little bit better. Anybody who wants to download and install the app, by all means, you can do. You can get it from the App Store. You just require iOS 15 or later. It's also available on Play Store for Android 9 or later. You just have to look for Hytune, which is Hytune. If you want to download that and try and play along as we're going, by all means, help yourselves. So without further ado, first we want to find the application within our device itself. So we're going to look for our Hytune icon, which is the one on the right hand side with the two cogs. And then once we enter, we're going to enter into the app itself. So from the main screen, we have a number of areas that we can choose from. We have the Hytune area, which is what brings us back to this screen. This is our home screen. And we can scan for active devices by clicking the Start Scanning Device button. We can click Configurations, which takes us into any previous built configurations that we may have. Obviously, most of you joining will probably only be using this for the first time. You may have used it already. So you will have some stored configurations in the background if you've used this with configuring a slider 160 or a 750 or whatever model it may have been. So we can build configurations for our devices within this area as well. There's also another area which allows us to push those configurations into the actuator when we're connected. And as I say, we have more, which takes us to settings within the app itself. So we can set languages, we can set the parameters on our units, so we can change our liters per second to liters per hour. We can change our pressure from kilopascals to bar or to PSI. And I'll go into some more of these in a little bit more detail later. So first, we're going to start by scanning for any devices that may be in the area where we're working. So if we click the Start Scanning Device button, that will then take us to another screen. This screen will start to look for any Bluetooth dongles or TA smarts that may be within the area itself where we're working. To connect to a TA smart, we actually only need a Bluetooth device, as in a phone or a tablet. The dongle, which you can see on the top section of the app, is a Bluetooth interface device that we use with the TA slider. The TA Smart is a different beast. That's a valve that we'll be discussing later on. This actually requires no dongle or Bluetooth bridge device between the two. You can actually talk to the TA Smart through Bluetooth directly from your device, as it has a Bluetooth 5 or BLE4 integrated within the unit itself. And as I said, to connect our slider, we actually physically need the dongle, which is this small little white device, which can be seen here. So this is our TA dongle. This plugs into the actuator itself, and it acts as a bridge, so enabling our communication from the phone to the actuator itself. So once the scan's complete, we'll be greeted with whatever devices are within the area itself. So from here, we can see there's a TA dongle and there's a TA Smart available within the area. So we can either select one or the other to start actually making configurations or changes or trying to interrogate that valve or commission that valve. So this time we're going to connect to the TA dongle. So we'll click the TA dongle and this will move us on to a little loading screen. And then once that's finished, we'll be greeted with a connection screen. So now we can see we're physically connected to an actuator. And in the USB section, see what actuator it is. So the dongle knows what PA slider it's connected to as soon as you plug it in. We also have some other information, so we can see the battery level of the TA dongle. There's a 1400 milliamp battery within the dongle itself, and this needs charging through a micro USB adapter on the bottom. We also have a remote control option, which I'll go into a little bit more detail. This is where we can actually physically see our configurations on the TA slider itself and what's actually happening with the actuator while we're in a semi-live state. So we can't adjust anything, but we can see what parameters are changing. And configurations, same as the previous screen, we had the configurations button at the bottom. This does the same thing, but it means we are already connected to an actuator. So this will allow us to physically upload configurations from this point into that actuator. So if we click the identifier tab, this is going to give us various information about the actuator itself. So from here, we can see what firmware is listed, what the serial numbers are. We can see the firmware of the TA dongle, and we can also see the firmware and the serial number of the TA slider as well. We can also do a reset actuator to factory settings. So if we click on the text in blue, which says reset actuator to factory settings, this will automatically wipe any configurations that may already previously have been stored on that actuator and take it back to its original configuration. So out of the box, that means this actuator is a 0 to 10 volt actuator with a linear characteristic that will fit on the TA modulator. So that means if you've joined our previous webinar where we discussed our TA modulator, we have an EQM characteristic built within the TA modulator itself. This means we only need a linear characteristic on the actuator. So out of the box, it will just work straight away onto a TA modulator. And all we need to do is wire that correctly, and it will just work as a standard 0 to 10 volt actuator that can be driven from the BMS from 0 to 10 volts, and it will just work. Obviously, that means we have to mechanically set TA modulator as well. We'll discuss that in a little bit more detail because we can actually set those flow rates through the actuator without having to set the valve mechanically. And then if we just click the high tune button on the top left corner, we'll return back to our main screen. So from the main screen, we're going to build a new configuration. So if we We can do this either live, which means if we tap the picture of the actuator and the TA slider, we go into a live view. It can be done this way. Typically, I would say don't, because we can change settings within that configuration if there's something already uploaded to the actuator. And if you're not quite sure what you're doing, you can press something and you can obviously stop it, prevent it from working. By building a configuration, you do this in a non-live environment, so we can actually make sure that we're 100% exactly what we want to do from a configuration point of view, and then force that upload onto the TA slider itself. So if we click the configuration button at the bottom of the screen, it takes us to our configurations page. But from here, we can build a new configuration by tapping the orange button in the bottom corner, which is a little plus symbol. We can also view all configurations that may already have been stored. So when we tap all, this will show every configuration that's been built. We can also split those, so we can group them by TA slider, so it will only show all TA slider configurations. And you can also click Smart and it will just show you all TA Smart configurations. However, if we're working on a project, this is just a standard configurations page. So if we press back, we actually enter the folders section. So within the folders section, we can see we have a folder called configurations and there's a 0 inside, which means there are no configurations built within folder yet. What we can do is click the button in the top corner and we can start to build our own project folder. So if you have a brand new project and you want to keep all of your configurations built within that project so they don't go to other projects, or if you're working on multiples, we can keep them all neatly together. So by clicking the top button in the right corner, we come to a create folder window. All we do now is click in the white bar on the middle. We type our project name, and for this purpose, we'll call it project test. And then we'll click the save button. And then we have project tests ready for us to start building configurations into, so we can walk on site and physically start uploading those configurations to the actuators. And this can all be done before you actually start any commissioning procedures or testing. This can all be done from a desk environment and physically build one of these. Once you've built one, you can also copy the same configuration and make a slight change to the copy and save that as something else, which is particularly useful when you've got multiple fan coils on a project or terminal units of, a large multitude with slightly different flow rates or a slightly different valve. We can literally just change some of the initial configurations within the first one and save that as configuration 2, configuration 3, and just carry on so on and so forth to make those changes. So if we click the project test, we now enter our area where we can build a configuration. So if we click the orange plus in the corner, this will then bring up a window asking us what we want to do. So do we want to build a configuration for a TA slider, or do we want to build a configuration for a TA Smart? So in this instance, we're going to click TA slider, and that will take us to our TA slider actuator configuration page. Now, out of the bat, because we're not doing this live, we're building this in a boxed off environment. We need to tell the actuator, we need to tell the configuration what actuator we want to be able to work with. So we're going to change the actuator selection first, which means clicking on the slider 160 in the corner, which is grey. This is our default selected actuator. So this one will automatically be there. So if we change our family and we click in the actuator family box, this takes us to a list, which allows us to select whichever version of the TA slider we're particularly using. So 160, 500, 750, and so on. And there will be a blue tick against the actuator that's selected. Once we've selected the actuator, we can then click back on the actuator button. and then this will take us back to our actuator selection screen. Within this selection screen, we can pick which version of the slider 160 we're using. In this instance, we're going to keep it with the default with the slider 160. But if we click the slider 160, which is grayed out, it will take us to a new page where we can physically see all of the versions of the slider 160 that are available. And as you can see, there are quite a few. So we have the input output, which allows a binary input from another device that can force the actuator to do something based on that, whatever that input is. So a window, if there's an actuator on the window and the window opens and you've got the heating on, that will send a binary signal back through the BMS, which then sends that to the actuator and tell the actuator to close, because there's no heating required anymore because somebody's opened the window. We also have the changeover version, which is for 6-way valves. We have the plus, which has a relay in, so we can actually get feedback signal from the actuator, so we can get position onto the BMS and it will tell us what the position of the actuator is currently sat at. And then we have our various backnet and Modbus versions and our failsafe. So we're going to select the slider 160, and as I say, the blue tick will appear next to it. And then once we're done, we'll click the actuator button to go back to our actuator screen. And again, we're going to finish here and go back into our configuration. So then we need to look at changing our input signal. So we need to tell our actuator how we want it to behave. If we're operating on a 0 to 10 volt input signal, we want to tell it how it intends to work. So if we click input signal, we can see that we have a standard screen. It's already set in proportional mode and the signal range is 0 to 10. And as you can see from the graph below, we are closed at 0 volts and then open to fully at 10 volts. We can make some subtle changes within these configurations. So we can change our control type for a start. So if we click proportional, it'll take us to a new list. And from here, we can see we have proportional split range, proportional dual range. So if we want to choose proportional split range, we go back and we can see another screen. I'll try and keep these a little bit condensed because there's a little bit more work behind what actually goes on, but this is just to give you an overview of what you can do. So from here, we can have our signal type set to a split range, which means we can operate this valve between 0 and 5 volts instead of 0 to 10 volts. Why would you want to do that? Well, you've got a heating and cooling valve and you've got one BMS point, or you want to reduce the amount of BMS points throughout the building. We can now use that one BMS point, which is going to deliver our 0 to 10 volt signal, and split that across 2 valves. So we can have the heating between 0 and 5 volts, which we'll set in this way. And then the cooling, we could set in the opposite way. So it operates between 5 and 10 volts. This does half the control. So you do affect the amount of control and the controllability across the valve. But it's a finite point that you might want to look at. It depends on how critical you really want it to be. And of course, the most critical point is that we're still controlling at this low end. And even with splitting the voltages, we can still control to low flows for 80% of the year, where we're actually only at 20% of the flow. You can also change this to proportional dual range. So this means now we can do heating and cooling through one valve. So we can split this to set the signal type between 0 and 4.5 volts to operate the heating, and 5.5 to 10 volts. So there's a little bit of gap between the middle. So there's some crossover. So there's no chance one voltage can affect the other, and we end up with heating and cooling on at the same time, or trying to confuse the actuator into what it's doing. We can also swap this, so the little orange button in the middle with the 2 arrows, we can swap how these work very quickly just by pressing the 1, and it will swap from cooling to heating, from heating to cooling with just the click of 1 button. Below, you can also see stroke. Now, I've actually physically set these valves up already. So the cooling is set to 0.09 litres per second, and the heating is set to 0.05 litres per second. By setting these within the app itself, so by going through stroke into the next window, it will determine how much stroke I need to give me that flow rate at design, 100%, shall we say. So our 0 volts on heating because we're coming down, and then our 10 volts on cooling because we're climbing back up. So you can actually physically have now 2 flow rates within one valve, and we can force that to do heating or cooling just based on the voltage itself. So we'll change it back to proportional, which is how we typically come out of the box, and we just click our input signal, and this takes us back to our main screen. We can also change how this works, so we can have this direct acting, which is 0 volts at closed and 10 volts for fully open. If we click the reverse button, we'll do the exact opposite. So as you can see, the graph has changed. So now at 0 volts, we're at fully open, climbing down to 10 volts where we're fully closed. And for this instance, we'll just set that back to direct, which also, again, changes the graphic. And then with the signal range, we can physically set this to change between 0 to 10 volts and 2 to 10 volts. So we can actually have a cutoff at 2 volts where we're fully closed at 2. Once we're happy with our selection, we can go back to our input signal and then press back again, and we'll come back to our main screen. The first thing I tend to typically change when we're building these configurations from this point in is the valve. The actuator will not know what valve it is intended to work on. You physically have to tell it within the configuration what valve you are using. Now, if you're using something that is not an IMI product, the standard setting is no valve, push to close. All of our control valves, or balancing and control valves, I should say, are push to close. So this is out of the box standard. This will just work a normal control valve. What we can do by clicking our valve is jump into another screen where we can change, instead of keeping it at push to close, we can click from IMI Hydronic, which further then extends the window. So this allows us to select our family, what type of control valve it physically is, and the valves within, and the valve itself, so we can choose what DN size it is, so 15, 20, 25, and so on. So first we'll change the family of the valve. So if we click, this opens a list, which, as you can see, gives us a varied amount of valves that we can physically select from, such as our TB, VC, and CM, which are our standard balancing and control valves. Our compact P, which is our linear PICV, and the modulator, as I say, is a default tick because that's what it's expected to work on as it comes out of the box. For this instance, we'll keep with the TA modulator itself, and we'll just select modulator. The tick will go blue on whatever you've selected, and then we just click valve selection to go back to the previous screen. From here, we'll click valve, and then this will open a secondary list, and this will give us all of our our DN settings, DN selections for the valve itself. So 15, 20, 25, 32. Again, we'll keep with the 15 just to keep things a little bit simple. And whatever you select, the tick will also appear against, and then we'll just click valve selection to go back. From here, there's a secondary function where we can send flow data to actuator. Now, what this means is we can physically see a flow rate on the remote view, on the remote screen, which we'll see in a little bit more detail later. This isn't a flow measurement. It is literally a theoretical flow based on the position of the actuator currently. So it's what you should expect to see at that position. So it gives you an idea of where you are from a flow rate point of view. If you don't keep this ticked, you won't see it within the remote view. But if you do open it, as we will, it goes green, and we can just press back and go back into our configurations. We can also set speed. So the speed is the speed the actuator actually travels. There are a limited number of choices to choose from. What I would suggest is, unless you need something specific, I'd keep this as a default setting at the moment. So as you can see, this is 10 strokes per millimetre. We're also going to make another change, which is our stroke. We're actually going to physically set the flow rate through the valve by the actuator. So out of the box, the valve will come set to setting 10. If you want to mechanically change that to deliver a flow rate, we will change that to whatever setting is given based upon our schedules and our selections. So if you want smaller flow rate than 0.133, which is out of the box at 10, we'll give you a setting. So if it's setting 5, you move the valve to setting 5. There are some ways of doing that. Obviously, it's a very small hand wheel, and sometimes within the positions that these valves are setting, it's not exactly the easiest thing to be able to go out there and physically look and to see where those settings are without torches and mirrors. And honestly, when you're physically on a ladder 30 feet in the air, it's not exactly the easiest thing to do, especially when you've got your hands full. It's also not very safe either. So ideally, this takes out all of those factors just by plugging in the TA dongle. Even if we did this live on site, we could physically plug the dongle in and get back down. And all of this can be done from a safe point of view on the ground. So if we're going to set the valve digitally through the actuator itself, we need to click our stroke selection. This then takes us into our online configuration, where we can see what the max actuator stroke is, which on a slider 160 is 6.9 millimeters. Now, the max valve stroke is shown as 4.02. This is because we've already told the configuration that we are using a TA modulator DN15. So if we want to change the stroke and limit the flow, we click stroke limitation, which opens up a smaller menu underneath. And we just need to click the stroke limitation box underneath, which takes us to a stroke limitation setting area. Obviously, we don't want to set on stroke because realistically, you don't really know what the stroke is for the flow. So we're going to select flow on the stroke limitation based on, which then changes the grey area for limited stroke and opens the white bar for the limited flow. This means we can now edit that section. So if we click into the flow rate itself, it comes up with a little cross. We can press the cross button and we can start to enter our flow. Now, what you will notice is just above the numbers, we now have min and max. So we have a minimum of 0.00345 and a max of 0.133. This is our minimum and maximum settable flow rates for the DN15 valve. This is because we have already told it what valve we need to be working with. So this now shows what our maximum and minimum flow rates are. So if you're working with these valves and you have a physical copy of a schedule, or you have something in Excel and you're looking at these flow rates as you're setting these up, and you come across one and all of a sudden it's actually this flow rate isn't permittable, then something's wrong. So it's an indicator that you may have either selected the wrong valve, or you may have picked the wrong valve within the configuration and you just need to go back and change it. So it's a small but good fail-safe touch. So if we click the X, we can now enter our flow. And for this one, we put 0.08 litres per second. Once we're done, we can physically press the done button. And then that will take us back by clicking stroke on the top left corner. And this will bring us back into our main configuration page. What we can then also do is see our general settings. So this is the last setting within the configuration itself. In here, there are some other things we can do, and there are other ways we can make the actuator perform in the way we expect it to or want it to. So if we click in general, firstly, we can see we have a list. We have calibration, characteristic, error settings, and other settings. So if we select calibration, this will take us into how the calibration is performed by the actuator itself. Firstly, by power on. So as soon as the actuator is powered, we'll force a calibration. Now, it's worth noting that on first initial power on, you should be on top of the valve. You should have the valve connected to the actuator. The actuator should not be dangling on its own while that initial power up is set up. So obviously, if there's any flushing within the system or someone's been working on it and took the actuators off before the BMS goes on, then make sure that you actually physically put those actuators back onto the valve before that power up, as it can cause issues with the actuator itself because it doesn't see a resistance as it's expected to see. So it will continually drive until it does, which can cause an issue with the actuator itself. So if we pick calibration mode, we can now tell it what to do on power on. So we can either choose full calibration, which is our default, the fast calibration, or no calibration. So you can actually stop it from calibrating on power up as well. In this instance, we want full calibration just to make sure that we physically do a full calibration of the valve and make sure that the stroke available is correct, and then we're setting at the correct position. I'd advise to keep this in full calibration realistically, unless you need something to work very quickly from a setup point of view. So then you could choose fast. Once we've chose, we can pick the one we want. The blue tick will come up again as previously seen, and then we can click calibration and it will take us back to the setup screen. We can also change the calibration refresh settings from here. So the frequency as a default comes as never. If we click that never box, this will take us to a new list where we can force a calibration every month, every week, or never. So this will physically cause the valve to calibrate either every week or every month on its own. So when it's not in a usage period, it will force a calibration once a week or once a month. This is quite a good practice because you actually are physically exercising the valve by doing this. So I would really recommend that you set this to every month or if you want every week, and just get that physical movement of the valve, and it will stop anything sticking, especially if things are in a state where once installed, they might not be ready to be commissioned for another 3 or 4 months or a little bit longer. They might sit in a state that's even longer than that, waiting for someone to come in and do some secondary works while the next tenant takes a floor of that building. So it's worthwhile doing just because you can guarantee that your valves are being exercised and they're not going to seize or stop working, which is going to cause issues. Once we've done, pick the one we want, and then just press back for calibration, and we'll go back into the setup screen. We also have an ignore the detected stroke. I wouldn't recommend ticking this. This actually ignores whatever is detected by the actuator of the valve. Realistically, this is something that we would probably do from a test purpose in factory, and wouldn't recommend that you actually physically choose this setting. It's more from an IMI setup point of view. So to return to the general screen, we click general in the top left corner, and we come back to our general setups. The next selection we can make is with our characteristic. So out of the box, again, the characteristic is linear. As I explained earlier, when we're working with TA modulators, which are an EQM valve, we only want a linear characteristic on the actuator itself. However, we do make a compact P, which is a pressure independent control valve that has a linear characteristic. So when we're using those compact Ps, because at the moment the compact P tends to do our very, very low flows, There is a TA modulator in the works at the moment where we will release a low flow version, but at the moment we use our compact P. When we use the compact P, it's important that when we set that up, we change the characteristic. So if we click the characteristic, we need to change that to EQM, which will change the curve on the graphic. You can do inverted EQM as well, but I wouldn't recommend that unless it was a specific application. So I'll say, because this is a TA modulator, we're going to keep it as linear, but it's just to show you that the functionality is there. You have other valves that we need to change for. Excuse me. So once selected, we can just press back on the general, and this will take us back to the general screen. From here, we can also see the error settings and the way the way the actuator is set up to handle specific errors. So if we click on error, it takes us into our error settings page, where we can see we have a number of things going on. Our optional waiting position, which is at the top. This tells the actuator what to do when we want it to go to a waiting position. So we can set that waiting position to be either fully extended, which means it will close the valve, or fully retracted, which means the stem retracts and it will fully open the valve. Our error 1, which is a 1 violet pulse on the LED itself. So on the back of the TA slider 160s and 500s, there's a small LED. On the larger versions, there's an LED at the top. Slight colour change with the 750s, 1250s and 1600s. These tend to have a green LED with a red LED for error. The smaller 160 and the 500s, they have a blue LED for I'm working and a violet LED to say there's an error. So if there's 1 violet pulse, it means there's a low power supply. So there's something wrong with our 24-volt power supply. For error 2, we have our input line break. So we can actually change this and make this go to a waiting position. So if there is an input error on the 0 to 10 volt analog signal, so if that's broke all of a sudden and we're no longer receiving that 0 to 10 volt signal, we will typically get 2 pulse flashes, 2 violet flashes on the actuator itself to say that the input's actually broken. Here we can physically set that to go to the waiting position. So if there is an interruption in input signal, we can force that actuator to either fully open the valve or fully close the valve, depending on how you want it to perform. You can also just leave it as it is. It will stay in the same position. It will just show the fact that there is an error. With error 3, this is 3 violet pulses. So this is valve clogging. If we have a blockage physically within the valve, this will report the 3 violet pulses. And automatically, as default, we have perform unblocking attempt set and go to fully open valve. So this means the valve will try to drive the actuator open to its in-volt position to allow more flow through. We don't physically set the valve, and we have that valve set to 10. We can force that actuator past its design to fully open at 4 mil or 6 mil, whichever valve we're using, or even more 15 and 30, 20 mil and 30 mil, depending on the size of valve we use. But we can actually physically force it past its set point when we set the valve digitally through the configuration itself. So as I say, we set this valve to 0.8 and we had a certain amount of stroke. We can pass that with these go to fully open valve setting, and hopefully this will flush anything that's within the valve itself. Our next error is stroke detection failure. So this is where the actuator is physically saying, I am no longer connected to the valve, I can't see it. This will go into four violet pulses, and we can also tick this to say go to the waiting position as well, and exactly the same as the input out of range. If the input goes out of range of the 10 volts and 0 volts or 2 volts, we can force this to go to our waiting position as well. Once we've made any selections in here, we can just click general and we'll go back. Obviously, we have other settings. So in here we have monitoring periods, which can be applied based on valve blockage protection. So we can ask this to do this every week or every month. And we also have an applied hysteresis. So this is telling us what change of input signal it has to see before it makes a change to the actuator. As a standard, this is set to 0.2 VDC. We can also change this to 0.1 or to 0.5, so it will see half a volt before it makes a change. But obviously, this is going to have an impact on how the valve controls. So as a default, it's set to 0.2. We can apply some subsampling, which is also automatically done. And we have the active LED. So the LED is always on. If we have a building where these LEDs can be on show, because we have a lot of buildings lately where we have no ceilings and everything is fully viewable to the occupiers, we can turn those LEDs off if they cause a distraction. So just by unticking that button, the LED will shut off. Now, obviously, this can create another problem because it won't show errors. But if you've got other versions of the standard actuator, you can force feedback from an error onto the system, onto the BMS, and we can physically get an alarm on the BMS to say that there is an error, that the input line is broke, or there's no 24-volt power to that actuator anymore. Startup delay, we can actually, so if there is an interruption in 24-volt supply, so power goes off, we can change that so we can delay for 2 seconds, 3 seconds, 5 seconds as a maximum before it starts to operate the actuator. This just allows a stable state. So as soon as there is enough voltage at a continuous amount of time, the actuator will then say, right, okay, I'm fine to work, and will carry on doing its job. As a default, this is just set to 0 seconds, so it will just start as soon as power up. It's as soon as the 24-volt power is returned to the unit itself. And just by clicking general, we can go back. And then if we click back, we go back to our main screen. So from here, we can either, if we were working live, we could generate a PDF report, which is by clicking the orange buttons at the bottom. This will physically generate, you have to save it as a name first. This will generate a full report of every setting that's made within the actuator that you can physically send to us, and we can inspect that for you if you have a problem on site or you have a problem with an actuator. You can send us those settings and we can go through that and physically look at it and say, right, okay, you've selected the wrong valve, or you've got the valve working in a voltage that it's not supposed to be, or in an action that it's supposed to be because it's reversed, but you want it direct. So it gives us some scope to be able to further inspect the valve as well. So if we click save, it opens a new window. We can call it a new name. So for this, we'll just call it test 1. And just by clicking in the white box, we can start to type. And once we've physically given it a name, we can click save, and that'll confirm. So this will now save in our project tests folder. So we have this available to use for any actuator within that project, or if you wanted to copy that out for another project, you could do so and just move the copy into another folder. And then to return to the main screen, we just simply swipe down from the top, and this takes us back to our view. So from here, we can physically upload the configuration itself. So if we click the configurations button, this will take us back into that configuration screen. Only this time, as we're connected to the actuator, we can see there's a little orange dot next to it. This means we're connected to a slider 160. So any actuator you connect to will show an orange dot on the configurations that are available for that particular unit. So if underneath there was another configuration for a slider 750, that wouldn't show an orange dot because we're not connected to a slider 750, but it will show one for the 160. So if we press and hold this, we actually come up with a second menu then, which allows us to do a number of things. We can push that configuration to the TA dongle itself. This is particularly useful for multiple projects where we have the same flow rate for various units. So, say a 300 fan coil job, for instance, you can run around, every fan coil's got the same flow rate. You can build that configuration into the dongle, and without physically using the app to do it, we can use the dongle to physically upload the configuration to each actuator itself. We can also just press the orange button, which pushes to the actuator. We can rename it, we can share it, so you can share those configurations with your colleagues, which allows you to quickly pass on a configuration to somebody else so that they can then start doing another section of the building, or so on and so forth. And obviously we can delete it. In this instance, we're just going to push to the actuator itself. So if we tick the orange icon, it'll push to actuator. We'll then get a window to say we want to confirm that we want to send the configuration to it, just in case you've clicked it by accident. We haven't, so we're going to click send configuration, and this will then go through a little waiting load screen, and then eventually will tell us that it's either failed or it's been successful. So we can see that the configuration is now stored on the connected actuator, and we can click OK. And this will physically then confirm that we've stored that configuration on the actuator. If we swipe down from the top again, we can return back to our main menu. From here, we can have a small play with the remote control application as well. So if we click remote control, this will take us into new window where we can see what's actually happening with the actuator live, but we can't adjust any of the settings within that actuator itself. What we can do is we can physically drive that actuator. So if we have no power to the BMS, or we do have power to the BMS, or we have no way of providing a signal to that from the BMS to the actuator, we can physically do an override. We ignore the BMS, or there is no BMS, to create our own power to the slider 160 and the slider 500. We can't actually physically drive the larger versions because they require more energy than the battery can give. So if we click the auto button, we put the actuator into an electrical override state. So now we ignore the BMS completely if there is a BMS present. This will physically change the LED to red. And now we can then press up or down to physically drive the actuator fully open or fully closed. So if we press the up button, it'll start to drive the actuator, and now physically on screen we can see that the position has changed. We're now at 3.21 millimeters of 3.21 millimeters, whereas before we were at 0. And we can also see that the design flow rate changed because we clicked send flow to actuator earlier. So now we're getting a theoretical flow rate based on position. And we can also see that the valve setting as well shown. So we have a TA modulator on the valve and setting, and the setting is showing 6.4 of 10. We can use this with our TA scope to physically take a flow measurement across the valve, and that's what we would input, that we were on a TA modulator 15 and the setting is 6.4 measure, and this will take a DP measurement across the valve and then give you a calculated flow based on the differential that it's measuring across the valve at that time. Can then press, so now we can close the valve. So we'll change the flow back to 0 just by pressing the down button. And the position also goes back to 0 of 3.21. So this is 3.21 is our maximum design setting. 0 is obviously fully closed. And you can also see that the valve setting has changed as well. So we're now 0 of 10 because the valve is no longer open, I should say, sorry. Then we can take it out of electrical override by pressing the auto button again. Once we've pressed that, the LED will go green, and then it will start to actually calibrate the valve. So anytime you take the valve in and out of electrical override, it will force a calibration to ensure that the valve is positioned correctly. Once we're done, we can click the high tune button and go back to the main screen, and then this will take us back to the actuator screen, the connection screen. And there is no more to do. We can click the X button, and this will take us back to our main screen. We do have a more button, which is in the bottom corner. So we can physically press the more button, and this will take us through various settings with regards to the app itself. So the license, diagnostics, and the application version. Some of these are particularly useful when you have a problem. If you use some of this with regards to the license and the about, which I'll show you shortly, it will give you the version number, and you can show what version of the app you're using if you're talking to us, so we can report that back to our ER&D teams and make sure that the app's updated correctly, or you're not using an older version of the app and it needs to be updated to enable a certain function. So if we click the region, we can select what language and what region we're in. This is the scroll, so we can wipe up and down across the countries that are pre-built into the unit itself. And once we've got the country we are in, we can press that and press OK and confirm that selection. So then take us automatically back to the more screen. Now from units, we can actually change how the information we get is delivered. So we can see our SI units. So from here, we can physically program each type of SI unit that we want to see. So in flow, we're in litres per hour at the moment. If we wanted to click that and change that to litres per second, the orange button next to it, which brings up another scroll wheel, we can scroll through the various units that we can physically see in, and all of the conversion will be done by the app itself. Once we're happy with that, we can select OK to confirm, and that will change physically within the app itself. And there are various others, so differential pressure, temperatures, so if you want to work in kelvins rather than degrees, power if you want to use kilowatts instead of watts. There are various functions within the units that you can change. If you click the about, this takes us to, as I say, our high tune version, so you can report on what version you're using, and we can make sure that you're using the latest model. And then the license, again, this is just literally the license agreement for using the app itself, and you can scroll up and down to read the full text and just press high tune to go back. There's also a diagnostic section. So the tab, if we just click it, this is when the last diagnostics was run. So this is just for reporting really for us. This will actually physically show in any PDF report that you produce, and this just gives a little bit more information to our ER&D team if there is a problem. And that brings us to the end. So just as a summary, we've seen how we can connect to the TA slider, how we can build our configurations and our folders, how to build a standard 160 configuration and uploading of that, and then obviously with our remote view of being able to operate that valve whilst we're in the remote view to see what we're getting from a flow point of view, from a position point of view, and then more and settings so we can make some physical changes within the application itself. Thank you for listening, and if you have any questions, feel free to send them over, or to jump in if you can unmute yourself or put your video on. By all means, it's not a problem.